wondered what will happen inside our body under starvation when there is a zombie apocalypse? The story begins when the world was under zombie attack and Ali, our character, has been starving ever since he was separated from his family. Immediately after Ali has gotten hungry, up until the end of the first day, the available free glucose source in the body has depleted. The body would prevent a continuous drop in blood glucose level by releasing hormones like insulin and glucagon. Insulin, that is used to promote absorption of glucose in body, will drop, thus reducing the storage for glucose. In turn, glucagon will be released and help elevate blood sugar level by using up glycogen storage in the body to be converted into glucose. This process will produce temporary energy that is needed by the body. The glucose then will undergo aerobic respiration through glycolysis, Krebs cycle, and electron transport chain. Nonetheless, this generation of energy relies a lot on the glycogen storage of carbohydrate, which will only be available for a short period of time. On day 1 until day 2, Ali's body is in starvation mode and chooses to generate energy using non-carbohydrate sources to control blood sugar level. So, in this case, lipid metabolism begins with beta oxidation to generate acetyl-CoA. Since triacylglyceride is stored in adipose tissue, lipase enzyme will break them down into fatty acids and glycerol. Then, fatty acids will enter the bloodstream and into cell where beta oxidation occurs. In cytosol, fatty acid will be converted into acyl-CoA via acyl-CoA synthetase, which consumes some ATP to activate. The acyl-CoA is unable to enter mitochondria and sits outside of the outer mitochondrial membrane as mitochondrial wall is selective. Here comes the help of carnitine shuttle to help transport acyl-CoA across the mitochondrial membrane. Carnitine will combine with acyl-CoA to form acylcarnitine at the transporter on outer mitochondrial membrane CPT1. Then, acylcarnitine is passed through the mitochondrial matrix via CPT2 in the inner mitochondrial membrane. Even so, acylcarnitine is not recognized by the oxidative enzyme, so it gets converted back into acyl-CoA, and carnitine and coenzyme CoA-SH will leave the matrix via another membrane protein transporter, which is CACT. Acyl-CoA now will be able to undergo beta oxidation. In the mitochondrial matrix, acyl-CoA will be oxidized by acyl-CoA dehydrogenase, where oxidation occurs at the C-alpha and C-beta. Protons attached to these carbons will be removed. This produces trans-enol-CoA simultaneously, where a molecule of FAD will be oxidized into FADH2. This FADH carries electrons, which later pass to flavor protein in ETC for energy generation. Trans-enol-CoA will be hydrolyzed by enol-CoA hydratase. Hydrogen and hydroxide ions will be added respectively to the carbon alpha and carbon beta. This produces L3-hydroxyacyl-CoA. L3-hydroxyacyl-CoA will undergo oxidation in which a keto group will be formed at the beta carbon atom. This reaction is catalyzed by hydroxyacyl-CoA dehydrogenase. NAD+ is reduced to NADH and hydrogen ions, where later will be joining the ETC. 3-ketoacyl-CoA is later being cleaved by thiolase, whereby CoA enzyme is added. A molecule of acetyl-CoA is formed and the original fatty acid chain has 2 carbon deducted. Acetyl-CoA here could directly enter Krebs cycle, then to ETC to generate ATP. Yet, at the same time, protein is broken down by the body in which amino acid into many intermediates that can enter Krebs cycle directly and proceed to ETC for ATP generation. The amino acids intermediates can join oxalic acetate, fumarate, alpha-ketoglutarate, and pyruvate. However, pyruvate cannot directly be phosphoenolpyruvate due to its high energy, but there are alternatives such as pyruvate to oxalic acetate by pyruvate carboxylase, oxalic acetate to phosphoenolpyruvate by pyruvate carboxykinase. The carbon skeleton of the amino acid can be broken into alpha-keto acid to become acetyl-CoA before joining into the Krebs cycle. After 3 days of starving, Ali's body becomes weak, but inside his body, protein-saving plants begin where protein metabolism is stopped to conserve protein and prevent muscle degradation. Nonetheless, there is no regulation for beta oxidation when a lot of ATP and acetyl-CoA is present. So, no feedback inhibition is done to slow down beta oxidation, but ATP can inhibit ETC where high concentration of NADH is present, which signals Krebs cycle to slow down. Hence, beta oxidation is slowed down to halt production of acetyl-CoA. Now that the concentration of acetyl-CoA is high, ketone bodies is produced in the liver through the elimination of amino acid, which will be converted to alpha-keto acid before entering the ketogenic pathway. Ketone body works as the fuel for energy generation, and it supplies the energy to the brain to keep Ali conscious, but it's not enough for strenuous activity. Although Ali felt like he was at the brink of death with no food and scared for his life, luckily he found a shelter after 3 days. There, his body was replenished with nutrient and he's no longer in starvation mode. Now, with enough energy, he can attack and protect himself from zombies. I think that's all from our group. Thank you for watching.